Hey everyone, and welcome to our explainer on the unseen world of dreams. Now, if you think your dreams are just, random neurological noise or some bizarre hallucinations that you just forget by breakfast, well, get ready, because the science we are uncovering today is absolutely going to change how you look at sleep forever.
Many of the health concerns we usually attribute to just, general sleep loss, they're actually the result of a silent epidemic of REM sleep deprivation. That's right, we are currently facing this massive crisis of dream loss, and it's an unrecognized public health hazard impacting our minds and bodies in ways we're really only just beginning to understand.
Okay, let's dive into this. Here is our roadmap for today. First, we'll look at the epidemic of dream loss, then the brain's visual bodyguard, the synthetic reality machine simulating our social world, two-way dream communication, and finally, the future of dream engineering. All right, let's get into it. Section 1. Epidemic of dream loss, the health crisis. We constantly hear about general sleep deprivation, right? But the specific loss of REM sleep, that's the phase where our most vivid dreams actually happen. Well, that's a uniquely modern crisis, and it's driven by our lifestyles, substance use, and a whole lot of widespread medications. According to clinical research by Dr. Ruben Neyman, this specific loss of REM sleep is a literal, unrecognized public health hazard. People often think, oh, I'm just sleep deprived. But actually, scratch that. They are dream deprived. And when we lose our dreams, we aren't just tired. We're losing a critical, active biological function that contributes to illness, depression, and, quite literally, causes an erosion of our consciousness. Moving right along, Section 2, the brain's visual bodyguard, defending territory. We absolutely need to talk about this radical evolutionary theory from neuroscientist Dr. David Eagleman about exactly why your brain hallucinates in the dark. To really grasp this, we have to look at brain plasticity. Now, our brains are highly adaptable. This means that our sensory regions are in this constant, almost aggressive competition for neural real estate. It's like a giant puzzle, and if an area of the brain goes unused, it's very quickly colonized and taken over by the other senses.
And get this, it takes only 60 to 90 minutes, literally under an hour and a half. Research shows that if you're tightly blindfolded, it takes less than 90 minutes for your visual cortex to start showing activity driven by touch and sound. Now, think about our evolutionary history for a second. We live on a planet that plunges into darkness every single night. In a pitch-black cave, you can still hear, smell, and feel, but you absolutely cannot see. Suddenly, your visual cortex is incredibly vulnerable to being taken over by those other senses while you sleep.
So what does this all mean? Well, dreaming is essentially the brain's defense mechanism. Every 90 minutes, your brain blasts the primary visual cortex with activity to protect its territory during the night. Highly plastic species like us humans, who are born completely immature, need massive amounts of REM sleep to constantly defend that visual real estate. Less plastic species, like giraffes, who are literally born mature and ready to run, require significantly less REM sleep. So your dreams are, for sure, your brain's visual bodyguard.
All right, Section 3, the synthetic reality machine, constructing the dream. So how exactly does the brain build this bizarre visual world every single night?
For a long time, the old view was just that dreams were random, chaotic replays of your day. But the memory theory of consciousness, or MTOC for short, flips this entirely. And this brilliantly illustrates the shift. Dreams are actually a dynamic synthetic construction. The brain reactivates thousands of memory fragments all in parallel, and then stitches a small subset of them together to create a consciously experienced storyline.
Recent analysis using advanced AI natural language processing actually confirmed this. The brain doesn't just passively hit replay on your life, it actively reshapes reality. It takes a familiar setting, maybe your childhood home or your office, and it blends it with your personal traits to create totally surreal, entirely new scenarios. It's this highly structured AI-like generative process happening right inside your head.
Section 4. Simulating our social world, the Avatar program. Now, if dreams are a constructed reality, who else is in there with us?
Well, the answer is almost always other people. In over 95% of dream reports, our dream self interacts with other simulated human characters. The social simulation theory argues that dreams actually act as a specialized evolutionary training ground for human interaction, completely populated by these simulated avatars.
Your brain is casting a very specific, carefully curated mix of characters every single night. Based on data from researcher Reverend Swa and his colleagues, 44% of these avatars are familiar people, 25% are total strangers, 19% are undefined, and 12% fall into an other category.
So why this specific cast? Well, dreams actually overrepresent strangers to force us to practice threat identification in a totally safe simulation. But here's the wild part. During REM sleep, you are 3 times more likely to engage in mind reading, attributing motives and thoughts to others, than when you are awake. Your brain is rehearsing critical evolutionary social bonds, essentially ensuring you're socially optimized for the real world when you wake up. It even strengthens connections with your loved ones.
Section 5. Two-way dream communication, breaking the wall. Okay, if dreams are this highly structured, interactive environment, can we actually reach into them from the outside?
8 minus 6, 2. It sounds like basic math, right? But this is an actual, historic, real-time exchange between scientist Karen Concoli and a sleeping volunteer named Christopher Mazurek. The researcher literally asked the math question out loud in the lab, and the subject answered accurately from entirely inside his dream.
Now you might be asking yourself, why on earth would you want to do math in your sleep? And hey, it's a completely fair question. But the point here isn't the math. The point is that the seemingly impenetrable wall of sleep has been completely broken by science. No way, right? Well, here's exactly how they pulled off this sci-fi level feat. First, the subject enters REM sleep. Now, because our bodies are completely paralyzed during REM but our eyes are not, the subject can signal that they're aware they're dreaming, a lucid state, by physically sweeping their eyes left to right. Then, the researcher plays an audio prompt. The subject actually hears it inside their dream, and literally eye signals their answer back to the waking world using pre-coded sweeps.
This represents a massive paradigm shift. It proves that complex cognitive tasks, like solving math and potentially even learning entirely new skills, are possible from entirely within the dream state. The dreaming mind is fully capable of high-level cognition, listening, processing, and responding, all while completely immersed in REM sleep. Finally, Section 6, the future of dream engineering. Now that we know this wall can be broken, how can we actively harness this untapped biological state? Scientists are already exploring targeted memory reactivation, or TMR. By using specific sounds or smells while you sleep, researchers can selectively trigger memory processing and actually influence dream content. Think about it. In a lucid state, you could theoretically slow down time and practice complex physical or social skills from within your dream, entirely free from real-world consequences or fear of failure. Imagine a surgeon practicing a highly complex technique entirely in a dream. So, the old advice to sleep on it is no longer just a catchy idiom. It's a scientifically verifiable method for generating creative solutions to vexing problems. Researchers are even actively developing smartphone apps to help everyday people achieve lucidity right at home. The ultimate goal here is to cue the dreaming mind to work on personal or even global problems while we sleep. We've seen today that dreaming is absolutely not just a side effect of sleep, and losing it is a true modern epidemic. It's a vital biological defense system, a sophisticated social training ground, and now a genuine bridge to two-way communication. So I'll leave you with this final, provocative thought. If you could bridge the waking and sleeping worlds tonight, what would you choose to learn or solve from within your own dreams? Thank you so much for joining me for this explainer, and I really hope you look at your own mind a little differently when your head hits the pillow tonight.